it's time for my favorite late afternoon game shows. Are they similar? That's right. Calm down, everyone. It's okay. I'm going to give you two figures, and we have to figure out if those two figures are similar or not, just based upon the wacky, zany information that's given. Let's take a look at the first candidates. So here are our first contestants. We have rectangle 1 and rectangle 2. We're told they're rectangles, ladies and gentlemen. We do know they're rectangles. The question is, are they similar? Let's take a look very carefully and see what we know about these two rectangles. Our first rectangle has sides 8 and 10. Our second rectangle, ABCD, has sides 12 and 15. Are they similar? Well, we can figure this out by taking a look at the ratios of corresponding parts and seeing if those ratios are equal or not. So, let's begin. So let's take a look at this smaller side of the larger rectangle and compare it to the smaller side of the smaller rectangle. So that's 12 over 8. And we can simplify that a little bit to 3 over 2. All right, so there's that ratio. Now let's look at the ratio of the other corresponding parts. So large side of large rectangle is to large side of small rectangle. That's 15 is to 10. And when we simplify that, we see 3 over 2, 3 over 2, 3 over 2. We have a winning pair. In fact, these two geometric objects, these two rectangles, are in fact similar because we see that the ratio of corresponding objects actually agree. Congratulations, folks. Great contestants. Let's thank them and give them some lovely parting gifts. All right, and now for our last contestant. Here we go. Here they come. Coming out. That's right. They are triangles. They are triangles. Indeed. We know. In fact, let me turn them around so you might be able to see it. There we go. Whew. That's right. Take your seats. Everyone calm down. Calm down. Big triangle. Good. All right. Now let's take a look at what we have. We know the various lengths of sides. We're also told that this angle is actually congruent to that angle. The question is, are they similar? Let's try a corresponding ratio and see what we get. So, let's take a look at the side opposite the Q, which is 12, and compare that to the side opposite the T, which is 9. So we see 12 over 9. And let's simplify this a little bit. So we can take out a 3. I guess there's a common factor of 3 on the top and the bottom. So I have 4 over 3. And so that's that ratio. Now let's take a look at the smallest side here. So let's take a look at the side that's adjacent, the small side adjacent to this double angle here. That small side is 8. Compare it to the small side here, which is 6. And so now I'm going to look at 8 over 6, which I can simplify a little bit. There's a factor of 2 on the top and 2 on the bottom, and so I see 4 over 3. And so this is looking very good, ladies and gentlemen, very, very good. We have an agreement here, and then there's one final thing to check, which is going to be this 18 versus the 12. So here we go, big finish. Let's see what happens. 18 over 12. And we simplify that, we see there's a factor of 2 on top and bottom, so this is actually 9 over 6. There's a factor of 3. I can simplify even more, and I see 3 over 2. Oh, no! 3 over 2, in fact, is not the same ratio as 4 over 3. These are different. In fact, therefore, these two triangles are definitely not similar. They looked so similar coming out, walking out here. We all thought they were. I'm sorry, contestants. We have some wonderful parting gifts, but they're not so great. The point is you can actually look at ratios, and if all corresponding ratios of corresponding parts are going to be equal, then we know the two objects are similar. But if one ratio of corresponding parts differs from another ratio of corresponding parts, then the two geometric objects are not similar. Thank you for joining us. We'll see you next week.